A cup of coffee is on a table in an airplane flying at a constant altitude and a constant velocity. The coefficient of static friction between the cup and the table is 0.3. Suddenly, the plane accelerates forward, its altitude remaining constant. What is the maximum acceleration that the plane can have without the cup sliding backward on the table? So in other words, we have a coffee cup on a tray and the plane accelerates, let's say, to my left, your right. Okay, so let's take a look at this, and it doesn't slip. Okay, so the cup and the tray are accelerating together. They're looking for the maximum acceleration so that the cup doesn't slip relative to the tray. Okay, we have the coefficient of static friction is 0.3. So we have mu(s) is 0.3. They're looking for the maximum acceleration, A max. Interesting problem because that's all we're given, really. So let's see, if we draw a free body diagram of the cup, and let's say we have an acceleration to the right, we know that there has to be a force of static friction to the right because the cup isn't slipping. And since it's on the verge of slipping because we have a maximum acceleration, we have the equation that Fs max is equal to mu(s), the coefficient of static friction, times the normal force. But the maximum force of static friction is what's accelerating the cup. So we can use Newton's second law. So we have the maximum force of static friction, which is the net force. Remember, the normal force and the weight balance each other. M is the mass of the cup, and acceleration max is what we're looking for. Solving for acceleration max, we get the maximum force of static friction over the mass of the cup. But the maximum force of static friction is equal to the coefficient of static friction times the normal force. And from Newton's second law, since there's no vertical acceleration, as we said earlier, the magnitude of the normal force must be equal to the weight. But isn't weight, from Newton's second law again, equal to the mass of the cup times the acceleration due to gravity? So we have A max is equal to mu(s), the coefficient of static friction, times the mass of the cup times the acceleration due to gravity, divided by the mass of the cup. Mass of the cup cancels. Maximum acceleration then is simply equal to the coefficient of static friction times the acceleration due to gravity. Pretty neat. So you see, it doesn't even matter if the cup is filled, right? Because mass cancels out. And by the way, if it does slip, which way do you think the friction on the cup acts? And what kind of friction is it? Okay, let me do that again. Well, it's sliding, so it would be kinetic friction, and the cup is accelerating to your right, so wouldn't the kinetic friction have to be also to the right? It turns out that kinetic friction always acts in a direction so as to oppose the relative motion between the two surfaces in contact, in this case the cup and the tray.